In this lesson, we're going to add some finishing touches and mirror the helmet. We've gone ahead and added another vent to the side of the helmet that was created much in the same way that the jaw vents were created. We've also added some vents to the front of the helmet that used the extruded surface technique with the split line that we've shown several times. So what remains is to mirror the helmet and add some finishing touches. The next feature that we're going to roll back is the mirror. And in this case, rather than mirroring individual features, we are mirroring the entire body. This should be faster than just mirroring individual features. There is an option, remember, in the mirror bodies feature that allows you to knit surfaces. Now, if surfaces start out unknitted, then those surfaces will not be knitted because of this option. But if a mirrored surface body touches the original, then those two bodies will be knit together. And the two halves of this helmet meet that requirement so that they will be knit together by the mirror feature. We can confirm that by going up to the folder for surface bodies, and we have just a single surface body after the mirror feature. Remember that we have some small cosmetic issues to clean up, such as this gap in the mouth vent. This is going to be fixed in 3 steps. The first will be a boundary surface that goes from one to the other using curvature continuous setting on both sides. And the second will be a fill surface used to fill up this 3-sided gap. Let's take a look at how this was done. I'll roll back the boundary surface, edit the definition, and we see that the 2 edges have been selected with curvature setting on each. This makes sure that the transition across this gap is as smooth as possible. To fill in the gap, we're going to use the surface fill feature. Now remember that Solidworks surfaces want to be 4-sided, and most of our faces here have met that requirement. But this gap that we've got is definitely 3-sided, and one corner of it is very sharp and pointy. This is generally a recipe for a big problem. So let's take a look at how the other one was done. The surface fill, if we roll this back, it's done this way. Select filled surface from the surfaces toolbar. And if all of these surfaces were knit together around here, we'd be able to just right click and say select open loop. But I can see from the light blue edges that we have open surfaces, which means that the boundary surface and the main surface are not knit together. So I'm going to have to select these manually. Let's go ahead, click on these. It's a good idea to set these to curvature right away. If you've got one set to curvature, the next one you select is automatically set to curvature. Now, this last one, we don't want set to curvature continuous. This one just needs to be contact. So when we select it, it fails. and that does give us the curvature that we need through the middle of the face shield. I click OK on that. The face shield is created with a nice shape, and that needs to be mirrored. But then we need to create also an inset area around the opening for the face shield to seat into. And this is a great use for the ruled surface feature. I'm going to roll it back and turn off the face shield and turn off this reference surface. To create a seat around the face shield, I'm going to use the ruled surface. Normal to surface, distance of 0.1 inch. I'm going to select the edges around the opening, and you can see that Solidworks is creating a small surface ledge that goes all the way around the opening. We're just going to do this twice. Another ruled surface, and now select the edges of the surface that we just created using the same settings, normal to surface and 0.1 inch. And you see we've created a bit of an inset lip for the face shield to be seated into. Hope you've enjoyed this lesson on creating a full face helmet. It has a lot of take-home information on surfacing and the details of how you get it done.